Greetings everyone, Fru here. Welcome to the DemoHub. In today's demo, we're going to go through a tutorial of Snowflake higher order functions. Now, what are higher order functions, you might ask? These are functions that take other functions as arguments and do transformations on your data. This allows you to do really complex operations on data while making your SQL more expressive and flexible. We're going to dive into a scenario to unpack what this is and how you can incorporate this into your data analysis needs. Now, this will be heavy on examples. This will be heavy on SQL statements because I think this is such a cool and powerful functions that Snowflake is making available for data analysis. To set the stage for our scenario here today, in this case, we have a table with customer orders. Very simple. It's a trivial example. Just bear with me as we walk through this. Customer ID and the date. We also have a JSON payload that comes with this. Open up the JSON payload. We see that this customer one, has different orders. There is a price, there is a quantity. Next, let's look at the task at hand. What we want is to write a SQL statement that can calculate the total revenue for each customer across all the orders. But we also want to filter and see just when the revenue is greater than a certain amount, 15,000 in this case. We take a look at customer ID 1. Quantity was 67. Price is that. If you multiply the price times quantity to get revenue, that's way more than 15,000. We definitely want to keep this. This one is not, price times quantity is not enough. We want to filter this out. In this case, 56 times 5 is not enough. 5 times that, that's 5,000, that's not enough. Go down the list. You can see the records you want to keep. You can see the records we don't want to keep. Now, there are ways to do this in SQL today. What we're going to show you is how you would do this today in SQL using another higher order function called lateral flatten. Then I'm going to switch at the end and show you how and why filter is such a cool thing. There's filter, there's transform, and hopefully there's going to be reduce. So this is a really cool thing to keep your eye on from a SQL perspective. Next, let's actually take a look at how we would start approaching solving a challenge with lateral flatten. If you're not familiar with this, I'll do a quick refresher of what that is. Essentially, you have the customer orders, which we saw. I'm going to do a lateral flatten, which basically takes that column, which is order detail, and print that to the screen. We're not doing anything fancy here, nothing to write home about. This is just basic lateral flatten. But what is interesting when we do lateral flatten is we're going to take this JSON and flatten that out. Here we have one row for customer, and in there they have 2 orders. If we need to sum and do filters, it's hard to do that when you have just one row with an iterable inside of that. So we need to flatten that out and then start doing summations and filtering on that. That's how SQL really works. Go ahead and run this statement. Now we see that customer ID 1, this is the device, the price, and the quantity. At this point, once we have it in rows, it's pretty, I think most people know how to group by and do aggregations at this point. This is the traditional way we would solve a problem like this using lateral flatten. For the sake of illustration here, I can go into the specific quantity, the price, do some algebra and solve the problem very quickly. We have customer ID 1, the quantity, the price. If you multiply that by that, you can create a new column and then just do a filter where that column is greater than 15,000 or so. Okay, this is the traditional way we would approach solving this question using lateral flatten. Now, if we wanted the actual JSON coming, we can bring that back. Now I have customer ID 1 and the revenue 15,000. Kind of a roundabout way of explaining this, but hopefully this laid the foundation for lateral flatten, how you would use this to solve what we're trying to solve. With this said, let's see how we would approach the same question using more of a functional style programming with a higher order function. In this case, we're going to do a filter with higher order functions. To give you an idea of what we're dealing with here, customer orders, there is a column there called order details. So this is that JSON column that we want. Now we will leverage the higher order function here. In this case, it's a filter. We say filter. Filter simply takes an iterable, a function, and it applies that function across the iterable. In this case, the iterable would be the order details. Think about it almost like a data set or an array that you want to pass. Once you pass this iterable, we pass it into a function. This is why it's called higher order functions. Here is a function that we are manipulating, but we are passing this into another function that will iterate through all of this iterable and apply the function to it. Okay, that's where this term higher order function comes in. It's very common. Python has it. Lambda expressions, that's very common. For each item in the order detail, we take the quantity times the price, do a check. Is that greater than 15,000? If it is, we keep it. If it's not, we filter out the record. Doing it in one line compared to what we did before, which was like several lines. I can go back to that code. Go ahead and execute this. We have the same result. Now, it doesn't look the way we had it before. If we want this to look the way we had it before, you can obviously do that by simply doing a filter statement, add a where clause to say where the array size is greater than 0, so we don't have this empty arrays coming back. Execute this. We should have a result that looked like before. In this case, we're using the filter higher order function. Go back, just a few statements above. The same, cardiac monitor, ultrasound, 1 and 4. But we've achieved the same thing, just using a different approach with the higher order function. And if you ask me, I think the higher order function is a little bit more elegant, something that is common in Python. A natural ask for this, in addition to filter, would be like transform. And that's powerful for inserting records into your iterable, into your array. The next one is reduce. I'll highly encourage you to take a look at the documentation in the description below. If you want access to this code, you can pause and recopy it from the screen. But if you want me to share access to it, I can give you a link to the GitHub where higher order functions is something that is new to Snowflake. I think it's really cool for data analysts that are looking to write SQL statements in a more elegant fashion. I would highly encourage you to take a look at this capability.